Welcome back, mathematicians. And this time we're going to talk about the factoring theorem. Okay, this is a good theorem to have, and when you think about it, it's kind of on the verge of common sense, in the sense that if we're looking for factors, we're looking for things that divide evenly, and we're also looking for x-intercepts, right? So if we set this thing equal to 0, it should come up with these factors, right? So what it states in your book is a polynomial f of x has a factor of x minus k if and only if f of k is equal to 0. And that sounds like a lot, but I'm going to write it in shorthand and then explain what that means, right? Or I kind of already did explain, but all right. So I'm going to say, in this case, try to save ourselves some room, right? So we could write that long thing down, but I could say f of x, that polynomial, whatever it is, divided by x minus k, divides evenly if and only if, so this is a symbol if and only if, or we can use the symbol IFF. So this goes back to our literacy, right? IFF for shorthand. Either one of those will work. Please only write one. I'm going to say it again. If you're listening, please only write one of these. It doesn't matter which one. They mean the same thing. If and only if f of k this time is equal to 0. So in other words, if this, it goes both directions, right? Which is why this symbol is a little bit more relevant to a lot of you guys. F of k is equal to 0, so it's a x-intercept. Therefore, it divides this polynomial evenly. Yeah, it should. And the reverse is true, right? If this term x minus k, whatever the k is, divides this evenly, in other words, without a remainder, then that implies, so it goes this direction, that it will be a factor, right? So let's look at an example here. We have show that x plus 3 is a factor of this polynomial. So what I'm going to do is I'm going to plug in f of, and again, I'm look at my term, I have a plus 3 here, but I have a minus k here, so this is actually a negative 3, right? So I'm going to put a minus 3, or negative 3, negative 3, negative 3, negative 3 in where I have an x, right? So let's see if this works out. We can only try, right? So I have a negative 3 to the 4th power, so negative 3 times negative 3 times negative 3 times negative 3. That's going to give me positive 81. And then I have a 3 times negative 3 cubed, so negative 3 times negative 3 times negative 3. That's going to give me a 3 times a negative 27, right? And then I'm going to have a negative 3 minus 3, so that's going to be a plus 3. And that's going to give me a minus 3, and I just dropped that term down. So let's solve this guy out, and it should become clear to me very quickly. What's going to happen? I have negative 27 times 3. That's going to give me a negative, so plus negative 81 for that term. Plus 3, minus 3. And again, if you guys are having questions about the algebra, write a question mark, a star, something someplace here to indicate that you had trouble at a certain spot, so you can ask me about it next time you see these videos. So, in any case, I have positive 81 times a positive 81 plus a negative 81. That's going to be 0. And I have a plus 3 minus 3. That's going to be 0. So I have 0 plus 0, which is going to give me, well, I'll write it out here. This term, or these two terms cancel each other out. These two terms cancel each other out, which should be just as 0. Okay? So if you're still with me, just to make sure we're still listening to these videos all the time, I want you to not write something. I'm going to put a smiley face right here for no apparent reason. I want you to not write that, and then I'll know that you're paying attention. Okay? That'll be very much appreciated, and I will catch you on the next video.